Boys and girls, you're welcome to our 11th lesson of mathematics. And today we have a new style of having mathematics. You will not be able to see me, but you'll be able to hear my voice, which is good. First of all, at the beginning of this program in mathematics, we looked at quadrilaterals, or the first teacher who started the topic handled one of the quadrilaterals, and that was a square. And today we are going to look at what we call a rhombus, and when there are many we call them rhombuses. And as we start, we need to look at the properties of rhombuses. 1. All the four sides of a rhombus are equal. Just as you see, I have my rhombus A, B, C, D, and there's a symbol that shows that all the four sides are equal. You must know that, you should know that, because at a certain point of time you'll be able to use these properties. Then 2, we are looking at the diagonals of a rhombus. The diagonals bisect each other. What I mean is, I have this blue line showing me one of the diagonals, and there's a red line showing me the second diagonal. The distance from this vertex, or from this corner up to the center, is the same distance from the center up to the other vertex, or up to the other corner. And that is why we say that the diagonals bisect each other. The same things apply to that one of the blue line. So our next property which you need to look at is that the diagonals of a rhombus are perpendicular. What do I mean by this? When you look at my center, I have this diagonal BD, I have the diagonal BD, and I have diagonal AC. If you look at the line diagonal BD and AC, there is a symbol of 90 degrees, a right angle here. So according to my point, according to my statement at this point, you see that angle AOD, this angle here, I don't know whether you're able to see my pointer. I can see you are able to see. My angle AOD is 90 degrees. Let's check the next one. Angle AOB, this angle is also 90 degrees. Then we have angle COD, this angle here is also 90 degrees. Then lastly, we have angle COB, this angle is also 90 degrees. So the diagonals are perpendicular. That means when they bisect each other, they make that angle of, or they create that angle of 90 degrees. Now, we have looked at those properties. There are others, but we want to look at those few so that we handle our next subtopic, that is finding area of a rhombus. Now, remember, at a certain point we say that the diagonals bisect each other and they form angles of 90 degrees. Now, if you look at this, we have all the four angles which were formed, and we decided to divide, or to bisect, to remove, to form triangles, and you're able to see 1, 2, 3, 4 triangles. Let's see whether our triangles can make up a rhombus. There are 4 right angle triangles. So let's see that. I'm putting the first one there. Let me move the second one. The second one is moving. It's exactly at that point. The third one is also running. It has reached. Then the fourth one goes at that point. So you can see that the previous rhombus is already here, and there are 4 right angles. And I believe at a certain point, you looked at how to find area of a triangle. And for that case, we shall look at how the formula comes about. Remember there, we still have our 4 right angle triangles. I want now to put them. The other side, I made them to form a rhombus. Right now, the rhombus that we had formed, we want to see whether those triangles are equal. Let's see. I'm putting yellow on red. Let me move another one on yellow. You can see there's nothing moving out, or there's nothing which is length. And the last one is there. There were 4 triangles. That means I just need to have that rhombus, and at the end I will have that formula that a half times base times height times 4 is meant to give me the formula for finding area of a rhombus. I can use these 4 triangles, this red, this the green, then this yellow, and this light green. So if I get the area of 1, then I multiply by 4. That will give me the area of the rhombus that I may feel like finding. So this is a formula which can assist you get the area of a rhombus when you have been given in terms of diagonals, or in terms of base and height. Now, still back to our rhombus. There's something I want us to learn on this rhombus. We have that shorter line. This shorter line here, you can see I gave it diagonal 1. We shall take that as diagonal 1. Then guess the longer one. Of course, the longer one will be diagonal 2. Remember, my 4 triangles are still there. My 4 triangles are still there. And if I'm to look at the light green from the corner up to the center is just a half of diagonal 1. I don't want the full diagonal, but I just want a half of diagonal 1. That's why you can see here I have a half D1 for diagonal 1. Then what next? Still, on the longer diagonal 2, we have this diagonal 2. I just want a half of it. That means I have a half D2, or a half diagonal 2. Now when you look at my half of diagonal 1, then you look at my half of diagonal 2, which triangle does it give me? It gives me this one, which is light green. And we remember these triangles are all equal. Now that the triangles are equal, we have 4 triangles. Since we have the 4 triangles, our formula, basing on the 4 triangles, remember half of D1 is my base. A half of diagonal 2 is my height. So I will have a half times a half of diagonal 1, which is my base, times a half of diagonal 2, which is my height. And since I have 4 triangles, then I will have to multiply by 4, because you can see I have yellow, I have red, I have blue, and I have green, and all those triangles are equal. That's why I'm multiplying by 4. Now, let us reduce by common factors. Now I'm going to divide. I'm dividing 2 by 2. What will it give me? Yes, it will give me 1. I should divide 4 by 2. What will it give me? Of course, 2. What next do I have? Oh, I still have that 2, which should be divided by 2 to give me 1. Then 2 on the numerator divided by 2 is also giving me 1. What am I left with? If you look at my numerators very well, I have this 1 times 1 diagonal 1 times 1 diagonal 2. Of course, this 1 will almost be the same. But remember, I have a half which is quite common here. We have a half which is not touched. But if you look at this work, this second half of diagonal 1 is no longer there. I only have now diagonal 1. Because 1 out of 1 is 1, and 1 times diagonal 1 will still give me diagonal 1. The same thing is done there. 4 is no more. Now what comes in next? That is what comes. A half which you see here is coming down here. Diagonal 1 which is here is coming this side. Diagonal 2 which is up there is coming this. The other halves are no more. So this big formula you see here, it is a half times diagonal 1 times diagonal 2 is going to be our formula for finding area of a rhombus when you are given diagonals. So when you have diagonals, that is the formula you are supposed to use. Now, we can now move to our next point. Let's try to apply whatever I have discussed with you or I've mentioned, whether it works very well. I know it works. Find the area of the rhombus below. Where is the rhombus? It's there. Let me draw. I have that. What is that? That's my diagonal 1. That shorter diagonal is my diagonal 1, which is 6 centimeters. I'm also bringing my longer diagonal. That is diagonal 2. So I have diagonal 1, which is 6 centimeters. Diagonal 2, which is 8 centimeters. My formula. I had 2. One was a half times base times height times 4 when there were 4 triangles. But right now, I'm only dealing with diagonals. That means I should apply the formula of a half times diagonal 1 times diagonal 2. Remember, my diagonal 1 is 6, my diagonal 2 is 8. So when I substitute, I will come up with a half times 6 centimeters times 8 centimeters. Now I'm going to divide. 2 divided by 2, because it will give me 1. 6 is an even number, 8 is an even number. Now I can divide any of them. Let me divide what I feel I should use for now. 6. 6 divided by 2. What will I come up with? 3. 3 has come. So what am I remaining with? I'm now remaining with 3 centimeters times 8, which is going to be my next step. So you can see there I have 3 centimeters times 8 centimeters. What is the product of 3 centimeters and 8? Mentioned before I put my answer. If you got 24 square centimeters, both of us are correct. You are right and I'm also right. That was our first example. Let's look at example 2. Find the area of the rhombus below. Look at that. I have diagonal 1. I have diagonal 1, which is from this corner up to this corner, or from that vertex up to this other vertex. What do I have? From the vertex up to the middle point is 6. Then from the middle point up to the last vertex is also 6. What will be my diagonal 1? Because my diagonal 1 will come up with will be 12. My diagonal 1 will be 12. Now, let's look at diagonal 2. I have from this vertex up to the center. From the vertex up to the center is 8 centimeters. Again, from this same center to the last vertex is also 8. That means the whole of this line is my diagonal 2. And to get the total length of diagonal 2, I will add 8 to 8, which will give me 16. That is if we are to use only and only diagonals. Now, let me bring my formula. My formula is there, which is a half times diagonal 1 times diagonal 2. Remember, my diagonal 1 is 12 centimeters, that is 6 plus 6. And my diagonal 2 is 16 centimeters, that is 8 meters. Oh, sorry, I'm talking about centimeters, yet they are in meters. Diagonal 1 will be 12 meters. Diagonal 2 will be 16 meters, coming from 8 plus 8. You can see I have times 12 meters times 16 meters. I should now divide. Now dividing 2 divided by 2, which is giving me 1. 12 divided by 2. What do I get? The answer is supposed to be 6. It has come. What am I remaining with? I'm remaining with 6 meters times 16 meters. And now what is the product of 6 meters and 16 meters? Make your side work. Get your answer. Your answer will come as 96 square meters. There we have used diagonal half times diagonal 1 times diagonal 2. Remember, still in that very number, you can decide to use the first formula we looked at, that is a half times base times height times 4, because each of these triangle has the base as 6 and the height as 8. That is if you want to use that, and the diagonals are not longer in use for that matter. But for our purpose of this lesson, we are taking this. Let's look at our next question, and there it comes. Our next question is in words, no diagram for now. That is, find the area of a rhombus ABCD given that diagonal AC is 30 decimeters and diagonal BD is 16 decimeters. Let me draw. Let's sketch. When you have a statement like that, please sketch your diagram. That's my sketch. A, B, C, D. Though my figure may not be very clear to you, but I have A, B, C, D. Let me try to expand. I think there it's better. Now from that point, I want you to see that AC has come, which is 30 decimeters. That is our diagonal. I think that's diagonal 2. It's longer. Then I have diagonal 1 coming in, which is 16 decimeters. What next comes in? The formula, which is a half times diagonal 1 times diagonal 2. You can see I have a half times diagonal 1 times diagonal 2. Okay, from that we now substitute. Our diagonal 1 is 16 decimeters. Our diagonal 2 is 30 decimeters. Let's reduce. I have that 2 divided by 2. What do I come up with? I'll get 1. Now, I have 16, which is an even number. It can be divided by 2. I have 30, which is an even number. It can also be divided by 2. One of them makes it very simple for you to multiply. Which one could that be? I think 16, because when I divide 16 by 2, I'm going to get a single digit. And multiplying a single digit by 30 makes it very simple compared to the other one. So let me divide 16 by 2. That gives me 8. Now what am I remaining with? I'm just remaining with 8 decimeters times 30 decimeters. And now what is 8 times 30? Even a P3 child can give you the answer because of the way I've simplified my division. My answer is going to be 240 square decimeters. Those were the examples I had planned for you using this wonderful system of Global Junior School. We can teach on chalk, we can use a chalkboard, or we can even use projectors for having lessons with you. So that marks the end of our lesson for today. Please go through the work very well and download the exercise Then you answer that work in your classwork book. The next teacher will come in with corrections. You will be your teacher, you will be your own teacher at home, mark the work. Then when time comes up for coming back to school, you need to bring that work so that we see whatever you have done and we see where we can assist you again when you are back at school. For now, have a nice time. I remain Odongo Geoffrey. Thank you.